All right, Algebra 2, Lesson 32, solving linear systems with matrix inverses. Doesn't that make us all sound really smart? All right, if I can do this, probably do just about anything. Okay, so a lot of this gets kind of wordy in it, so I'll try to cover it, and then the easier, what's going to make this make more sense is actually working out problems, because I can read off definitions and paragraphs, and we'll get lost in it. For me, I need to be hands-on with it in order to kind of see how this actually works. So if A is any n times n matrix, okay, and I is the n times n identity matrix, okay, the identity matrix is what causes it to basically get back to just the basic matrix that it already was. Then, you know, my matrix times the identity matrix equals the identity matrix times my actual matrix, and in the end, I'm just left with my actual n times n matrix. Two matrices A and B are inverses of each other if A times B equals B times A, and in the end equals the identity matrix. Okay, so if I multiply these two things and I get that identity matrix, which is, let's say in a 2 by 2, that would be 1, 0, 0, 1, right? If that's what I got whenever I multiply these two matrices, then these two matrices are inverses of each other. Okay, so we will recall that to find the determinant of a 2 by 2 matrix, we use the cross multiply, subtract, cross multiply, where we're multiplying the upper left by the bottom right, subtracting, and then multiplying the bottom left by the upper right. Right? We understand how to do that. So given a matrix saying n times n, matrix A has an inverse if and only if its determinant does not equal 0. So the inverse of matrix A is denoted A to the power of -1. That's our inverse. Okay. Keep in mind that anything to the negative first is the same as putting it in the denominator of a fraction where the numerator is 1. If A does not have an inverse, then A is called a singular matrix. Okay? So here we're getting to see some matrices, and this is really kind of the best I can do with the tools that I have here. So if matrix A was A, B, C, D, and AD, so cross multiplying from top to bottom, so AD minus C times B does not equal 0, then the inverse of A, or what we see down here, is D times A. Okay, so we flip the upper left and the bottom right. We switch those places, and then we don't switch the places of the bottom left and the upper right, but notice that we've made them both negative. Okay? And if I multiplied those things by each other, I would get an identity matrix of 1, 0, 0, 1. Okay? So 1 divided by AD minus CB equals D times D negative B negative CA. Okay, are we following some of that? Okay? It's, like I said, it can be a touch confusing. So using an inverse to solve a matrix equation. If matrix A has an inverse and the matrix equation AX equals B, meaning we're multiplying matrix A by a matrix, but I don't know what that matrix is, but I do know that it equals matrix B, and that has a solution, then the solution is that that unknown matrix is the same thing as the inverse of A times B. Okay, so we solve for X, right? We solve for this right here. Normally we would look at this A times X and we would divide by A, right? Right? That's how we would move A to the other side and solve for X. Well, we really can't divide by that matrix, but we can multiply by the inverse. It's kind of like that rule where we can't divide by a fraction, but we can do what? We can multiply by the reciprocal. That same concept is being applied to matrix equations where I can't divide by a matrix, but I can multiply by its inverse. Is that something that we can remember? Okay. All right. So if I've got matrix A times matrix X equals matrix B, and matrix A and matrix B are known, then I'm essentially multiplying both sides by the inverse of matrix A. Okay? What I'm left with is the identity matrix, and X equals the inverse of matrix A times matrix B. Okay? By definition of inverses. So X equals the inverse of A times B. Okay, again, all of this will make a little bit more sense when we break out our graphing calculators or even show some of this pencil paper. So when the matrix equation AX equals B is used to represent a system of equations, A is called the matrix of coefficients, X is called the matrix of variables, and B is called the matrix of constants. Give me a second here. All right. Let's see. So we got our matrix of variables, meaning we don't know what it is necessarily. That's what we're solving for. And B is the matrix of constants. We know what that is, and that's what our whole thing equals here. All right. So that should get to the end of that. Let's see if we have. All right. So some of this is a mix of 32 and 33. So we'll get down to some of this. What we see here is what we're working with. So we want to find the inverse of matrix A if possible. So hopefully what we remember in this, and you guys feel free to scroll down to the bottom and check the answer key. Remember, the inverse of a matrix is where we take upper left and bottom right and switch places, right? All right, so what is upper left then? -1. What's bottom right? -2. Do we switch places with bottom left and upper right? Yes or no? No. But what do we do with them? We change their signs. Yeah, we don't necessarily make them negative if they're already negative, right? So they may even be opposite signs from each other, right? One could be positive, one can be negative. All we know for sure is that we're going to change the signs of each one of them. So -4 becomes what? 4, and -3 becomes 3, okay? Now, what we would want to do is we'd probably want to test this, right? So let's see if there's a way to test this. All right, I'm going to break out our handy-dandy calculator. All right, and I'm going to make a 2x2 matrix based upon the original matrix A. So I'm going to come over here to Edit. We're going to make a 2x2. Let's see, -2, -3, -4, and -1. Okay? So if we've got all that, I'm going to hit second mode.
Are we going to put the negatives first?
I put everything in the way that it was originally.
Oh,
Okay? So now I'm going to go to second matrix again. I'm going to select matrix A, and I'm going to hit my little inverse button here. Do you guys see that?
I got lost right there.
Okay. So we'll do the same thing with 6 so you can see that. So let's see. Do I get they did not give me the same thing, did they? All right, well, let's see if I made a mistake, right? That's possible. Let's come down here to the bottom. What was this? Question number 5?
Yeah.
All right, looks like I did make a mistake, right? Because it looks like it matches theirs. So we got 0.1. Okay. Let's see. So it looks like we changed this sign and put it over 10. And then we did the opposite, and then so it looks like we took everything divided by 10. But we did change the signs. Okay. So I'm going to hit pause on this real quick and see. All right. So there is something that we want to look at. And it's found on page 234 in our book. It's in a box. It says the inverse of a 2x2 matrix. So it says if matrix A is A, B, C, D, and basically A times D minus C times B doesn't equal 0, then the inverse of A is 1 over the absolute value of the determinant of A. All right, so let's find out what the determinant of A is. Okay, what's -2 times -1? 2. Okay, 2 minus. And what's -4 times -3? Okay, so positive 12. So we have 2 minus 12, which is what? Okay, negative 10. And so what they're saying, if you look at page 234, is that the inverse of our matrix is 1 over the absolute value of, or sorry, 1 over, yeah, 1 over the determinant of A. Okay? Or it looks like, our absolute value of it, which would be 1/10, right? In our case, we're getting 1/10, okay, times everything here. Now, notice also that we do have to switch D and A. So we are going to switch, and we are going to get times -1. I think that maybe this is still -10 down here. Let's see. So -1, -2. Okay, we switch those two things. Okay, and we do get the opposite signs of what we had here. So this is 4 and 3. Okay, so I should wind up with my inverse should be negative 0.1. Was that what we had from our matrix? Okay. So then we should get negative point. Hold on, that would have been positive, right? It was positive? Okay. So 0.1, negative 0.3, negative 0.4 down here, and 0.2. Okay, does that make sense? Okay, so my mistake, sorry I left that out of the notes. Okay, let's try to get this right with this one. Now keep in mind, our calculator can't... Oh, sorry, I erased it. All right, well, let's look at number 6. All right, so the first thing that we want to do if we're doing this pencil paper is we want to get the determinant, right? So -4 times -2 is what? 8. So 8 minus, what's 9 times 1? 9. So 8 minus 9, right? What is that? -1. So I'm going to get 1 over -1, or just what? -1. So I'm going to multiply. Okay, now what do I need to do with this? I need to switch -2 and -4 here, right? And then 9 and 1. So the inverse, okay, is going to be 2, -1, -9, and 4. Okay, let's check and see if we're right in our inverse. Did you already check it? Oh, that's right, according to the answer key. All right, do you need to see how to do it in your calculator? Yeah, okay. So we're going to get matrix, second matrix. Okay, we're going to edit. I'm going to bring that guy here. Still a 2 by 2. Okay, and what I want is we want the original numbers -4, -1 before we've moved anything, -9, and -2. Okay, now we're going to get out. We're going to hit second matrix. We're going to go with matrix A, which is what we made, and hit inverse. And let's check. We got 2, -1, -9, and 4. We did it right. Okay, does that make sense? Yes. Can I help you after we're kind of gone through what we need to go through? Okay. Okay. All right, so let's look at 7. It says solve for matrix X. Okay, so what we want to do here, remember, is that we want to multiply our right side matrix by what? By the inverse of this matrix here. Okay? So our answer for X is 34, 18, 37, 21 times the inverse of our first equation. Okay? Let's see. So we're going to do this one full blown. Okay? Time. All right, so the first thing I have to do is find the inverse of this. All right, so I'm going to, what's that? We have time? What? Okay, all right, well, we should have time. So 8 times -2 is what? -16 minus What, negative 18? All right, so that gives me what? An answer of 2? Positive 2. Okay. So we are going to multiply, okay, and we should be getting negative 2, 8, negative 9, 2. Is that right? Because we need to get our inverse first. Okay? So we're going to multiply each of these things by 1/2. What's negative 2 times 1/2? Should be negative 1, right? And 2 times 1/2 is 1. And negative 9 times 1/2 is probably going to be what? Negative 4.5. Okay, something like that. And 4. Correct? Okay. So now what I want to do, we have all this and we understand all of that. Yep. Okay. So I'm going to make some space for myself. Okay. Is we want to multiply this matrix by this matrix. Okay. It's a 2 by 2, so I should be getting a 2 by 2. Okay. Okay. That upper left spot is first row, first column, right? So that's 34 times negative 1 plus 18 times negative 4.5. So it'd be negative 34. It's kind of a, probably need a couple of things in here. So 34 times negative 1 plus 18 times negative 4.5. I get negative 115. Okay? All right. My upper right is first row, second column. So that's 34 times 1 plus 18 times 4. Okay, I get 106. Okay, bottom left is first row, second column. Or sorry, second row, first column. So that's 37 times negative 1 plus 21 times negative 4.5. And I get negative 131.5.
That's what I got.
Okay? And then our last one is second row, second column. So 37 times 1 plus 21 times 4. I get 121. All right. So I could be way wrong, but go ahead and check the answer key. I'm way wrong?
That's 3, negative 5.
Oh gosh, we are way wrong. Okay. Well, in this case, I might, because let's see, we find the inverse. Should have multiplied by the inverse, and multiplying by the inverse, we should have gone through there. So let's see what our calculator gives us. And you check number 7 in the answer key? Oh yeah, we are way off. Okay. Well, we're learning as we go here. Okay. All right, so we got something like this. Let's see, in case I'm wrong here, but we should be looking at something like example 3 in your book on page 235. If we want to solve for x, we multiply by the inverse of matrix A. Okay, well, again, let me hit pause on this for a second. All right, so our calculator does give us the right answer whenever we plug it in. I'm trying to determine what it is that we've done wrong. But our calculator does get it right. Now, the only thing that I can see, like with example 3 in the book, is that what they went through to get the inverse for matrix A seems to be less than what we did. From our understanding of finding the inverse of a 2 by 2 matrix, if you look at their solution, they don't actually, multiply by that determinant fraction. What they did is that they essentially, what it looks like, is that they just multiplied, and I don't know if that'll end up changing anything here, but it looks like all they did was this here. And let's at least see what happens with our first couple of spots. That would end up being 34 times negative 2. Okay, so 34 times negative 2 plus 18 times, let's see, what, negative 9? I get negative 230 there, so I'm trying to figure out what it is that's different. I will tell you this, though, and so this is frustrating, and I know you might be frustrated with me, but your calculator will get the right answer there if you've plugged it in right. Does that part of it at least make sense? Okay, because there seems to be at least somewhat some conflicting information in terms of how to get the inverse and what that inverse is going to be. So, yeah, 3 times, hold on. We are, at this point, we're going to scrap the whole pencil paper thing. We're going to look at number 8, right? And we're going to solve this using our calculator. So we're going to set up what we see here, this 2, 5, 3, 3 is matrix A. What we see on the right, 14, 19, 21, 24 is matrix B. We're going to come into the ones we've already edited. They're already 2 by 2, so we should have 2, 5, 3, 3. Okay, second quit, second matrix, edit matrix B. Okay, it's still a 2 by 2. Let's see. Axel, did you ever figure out how to plug these in? All right, I'll be back there in a little bit. So 14, 19, 21, 24. Okay, and if we want to solve for matrix X, we want matrix A, and we'll get the inverse times, so we'll hit this, second matrix B. We'll hit this here, and we should get 7701. Is that what it says at the bottom? Is that what we're getting in our calculator? Okay. At this point, I'm going to pause again, and I'm going to try to help out. Number 9, do you guys know what you're doing with number 9? We're just typing this in as a matrix, right? And then we can hit matrix A, inverse, or to the negative first. I am interested to try this again to see if it actually will work, where we're doing the determinant and then multiplying by those things flipped. Okay. All right, so 2 times negative 2 is negative 4, minus 0 times negative 3 is 0, so we should just get negative 4 for that. Okay, so negative 4, and then we'll want to flip, so we've got negative 2, 2, and then the negative 0, positive 3. Oh, and this should be times 1 over negative 4, according to that chart that we saw down there. Okay, so I'm going to try some things. Negative 2 times negative 1 divided by 4 should give me, looks like, 0.5 or 1/2. All right, so 3 times negative 1 divided by 4. Negative 3/4. Now, is that what's in the answer key?
That's 0 and then negative 1. I said it wrong.
All right, but that's in the answer key. So that is done right. Okay. So that part of finding the inverse is still correct. I'm trying to figure out why a couple of these questions are coming out wrong. So I'll look into that. All right, we'll see you guys. You have a good day.